Hello and welcome to homework R.03. This was all about inequalities. All right, so let's take a look at number 1. On the set of axes below, solve the following system of inequalities graphically. State the coordinates of a point in the solution set. All right, so effectively what this means is we're going to graph both of these inequalities and we're going to do it all on one grid and kind of see where they overlap. All right, so let's start with this one right here. So y is less than 2x plus 1. All right, now there are two ways to graph that. You can either put it into the calculator. So I could type in 2x plus 1 and bring up the table and then graph 4 points from that. Or I can use the slope-intercept. The nice thing about doing it on the calculator is that with inequalities, we also have to worry about what side of the line we're going to shade, and the calculator can actually show that to us. So when you're in the y equals menu, if you scroll over using the arrow keys all the way to the left, you're going to notice that starts blinking. And when I start hitting enter, there's two that I want to focus on. One is this one that has the shading on the top. And you'll notice that kind of looks like a greater than sign, all right? That's the one we use for greater than. And then this one that looks like the L, or the less than sign, is the one that we use for less than. So this is y less than 2x plus 1. So we can take a look at that picture and just see that, oh, when we make our line, the shading is going to be underneath. Okay. So here's kind of the checklist that you wanna go through on these. Is one, you want to solve for y. Now on this one we don't actually have to do that, so the y is already taken care of for us. Step 2 is you're going to want to plot your points. All right, and that's either with a table or with the slope and the y-intercept. That's your choice. 3, you have to think about whether it's dashed or solid. And the way that you know is less than and greater thans are dashed, less than or equal to or greater than or equal to's are solid. 4, you have to do your shading. All right, and basically the way that works is when it's a less than or equal to, you're shading below the line. And when it's a greater than or equal to, you're shading above the line. And then step 5 is you want to make sure you put your label on it. So those are kind of the steps that you want to go through when you're doing one of these. So here we already have the y solved for. This 2, which we could write as 2 over 1, is our slope. So that means we're going up 2 and to the right 1. And then this number right here is our y-intercept, so that's where we're going to start our graph. We're going to start our graph at positive 1. So if I go over to my grid here, I'm going to start up at positive 1, and then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and then I can also do the reverse. Down 2, back 1, down 2, back 1, down 2, back 1, and so on and so forth. Now, because this is a less than, and there's no equal sign underneath it, I'm going to use a dashed line when I connect my points. So I've got my dashed line here. Okay. We already used the calculator to help us, but this is a less than sign. It kind of looks like an L. So that means we're shading below the line. Notice I'm not doing really heavy shading. That's because I still have another line to graph on here. And then I do want to put my label on this, and again I'm going to put my label up off the grid so that it doesn't get in the way of the next one. So there's y is less than 2x plus 1. Alright, so we've got this other one here, y is greater than or equal to negative 1/3 x plus 4. You can use the slope-intercept method, just be careful. When I see kids mess this up, it's usually the negative slopes that trip them up. A negative slope would mean that you're going down 1 instead of up 1, but you're still going to the right 3. All right. Now I'm actually going to just put this one into the calculator and get some points that way. I think that's sometimes a little safer. So parentheses, negative 1 divided by 3x plus 4. And then I'm going to scroll over to the right here, to the left. And this one right here that kind of looks like the greater than sign, that's what I'm going to use because it is y is greater than or equal to. I'm going to look at the picture just so that I know what I'm dealing with. And then I am going to bring up the table so I can get some points to graph. All right, so let's see. There's 1 point, -3, 5. Okay, so there's my table. So -3, 5, 0, 4, 3, 3, and 6, 2. Okay, just remember with the table, the x is your left to right, the y is your up and down. So -3, 5 would be back 1, 2, 3, and then up 5. 0, 4 would mean I don't go left to right at all, but I go up 1, 2, 3, 4. 6, 2 would mean I'm going, 3, 3, I skipped. Over 1, 2, 3, up 1, 2, 3. And then 6, 2 would be over 1, 2, 3, 4, 5, 6, up 2. And you can kind of just start to see the pattern there. I'm going down 1, over 3, down 1, over 3, and I could also do the reverse and go up 1, back 3, up 1, back 3. Okay? Now, in this case, we have the equal sign underneath our inequality, so that means it's going to be a solid line. So, connect these right here, and get my solid line. Okay. So I've got my solid line there. I'm going to put a label on it. Y is greater than or equal to -1/3 x plus 4. Now this one is a greater than. Greater than is above the line, so I'm going to shade up here. And what you should kind of notice is that over here in this top right area, I sort of have the double shading. I have the shading from the first inequality that went this way, and I have the shading from the second inequality that went this way. So right here where they overlap, this is my solution. So I label that with a big S there. And then it asks us to state the coordinates of a point in a solution set. So let's just talk about some of the points that would work. All right? This point would work right here because it's touching the double shaded area and it's on a solid line. This point right here would not work because even though it's touching the double shaded area, it's on a dashed line. This point would not work because even though the two lines intersect there, one of the lines is dashed, so that doesn't count. And then any of the points just in here in the double shaded area are also fine. So I'm just going to pick one well in the double shaded area. Let's say x is 1, 2, 3, 4, 5, 6, and then we'll make y 1, 2, 3, 4, 5. So way up in here. So state the coordinates of a point in the solution set. I could state something like 6, 5. That would be a point in the solution set. Okay, let's take a look at the next one. Given the numbers 18, 6, -3, -12, which ones are a valid solution to the inequality 2/3 x plus 3 is less than or equal to -2x minus 7? All right, so all we're going to do here is we're going to just solve this inequality and see which of those fall in our solution set. So I'm going to start by adding 2x to both sides. Now 2/3 plus 2x might seem kind of like a hassle, but just let your calculator do the work. 2/3 plus 2 gives us that long decimal, so we'll math bracket, and it's just 8/3 x. So we get 8/3x plus 3 is less than or equal to -7. We're going to subtract 3 from both sides. 8/3 x is less than or equal to -10. And then again, this might look weird, but we can just divide both sides by 8/3. All right, there's no reason we can't do that. And when we do that, let's see, -10 divided by 8 divided by 3 in parentheses so that we know it's a fraction. we get negative 3.75. And I'm actually just going to leave that one as a decimal. So x has to be less than or equal to negative 3.75. Okay. So if we were actually going to make a graph on this, it doesn't ask to, but if we were to make a graph, if you've got negative 3 here, negative 4 here, and negative 2 here, this is saying x is less than or equal to negative 3.75, so it's all of the numbers to the left of that right there. So if we look at our choices, positive 18 is not to the left of negative 3.75. Positive 6 is not to the left of negative 3.75. Negative 3, also not to the left of negative 3.75. Negative 12, yeah, negative 12 is going to be down here, so this is the only number that's part of our solution set. This is the only one that works for this inequality. Okay? Let's take a look at the back. Which interval notation represents the set of all real numbers greater than 2 and less than or equal to 20? All right, so here's kind of what you need to know about interval notation is less thans and greater thans are parentheses. So whenever we have a less than or greater than, we use the parenthesis symbol. Whenever we have a less than or equal to or a greater than or equal to, we use the bracket symbol. All right, so these are the parentheses, these are the brackets. And then if you ever see something where you need the infinity sign, so if it's like all numbers greater than 2, so it would go from 2 to infinity, infinities are always next to parentheses. Okay, so the infinities always go next to the parentheses. All right, so which interval notation represents the set of all real numbers greater than? All right, so greater than 2 is going to be parentheses because there's no equal sign under there. And less than or equal to 20, that's going to be a bracket because it has the or equal to part. So we're looking at this choice right here. Greater than 2 is why we have a parenthesis there. Less than or equal to 20 is why we have the bracket right over there. All right, let's take a look at this one. What is the solution of the inequality negative 6x minus 17 is greater than or equal to 8x plus 25? Okay, so if we just write this out here, negative 6x minus 17 is greater than or equal to 8x plus 25. I'm going to start by adding 6x to both sides. I get negative 17 is greater than or equal to 14x plus 25. I'm going to subtract 25 from both sides and get negative 42 is greater than or equal to 14x. Divide both sides by 14 and get negative 3 is greater than or equal to x. Now, notice on the answer choices, they always have the x's on the left-hand side. So if I want to do that, I can rewrite this, but just notice that the x is on the less than side. It's on the closed side of our symbol here. So we have to keep it next to the less than or the closed side of our symbol. So this would be x is less than or equal to negative 3, which we can see is choice 4 here. All right, let's take a look at this one. Which value of x is in the solution set of the inequality negative 2x plus 5 is greater than 17? All right, let's rewrite that here. Negative 2x plus 5 is greater than 17. All right, so we solve this. We subtract 5 from both sides. Negative 2x is greater than 12. Divide both sides by negative 2. Now remember, with inequalities, when you divide by a negative, we have to flip the inequality. So this goes from being a greater than to a less than. Now, a lot of kids, when they get this, they want to instantly circle choice 2, but what you have to remember is they're kind of trying to trick you there. It's sort of a trap. This says x is less than negative 6. It doesn't say that it's equal to negative 6. It says it's less than negative 6. So the only number up here that's less than negative 6 is the negative 8. All right, let's try another one. what value of x is in the solution set of the inequality negative 4x plus 2 is greater than 10? So again, we can just solve this one. There's room here. I don't even have to really rewrite it. Subtract 2. Negative 4x is greater than 8. Divide both sides by a negative 4. And again, because I'm dividing by a negative, this flips around and becomes x is less than negative 2. And again, this is the same exact trap, the same exact thing that you have to look out for. We're not going to circle negative 2. This is x is less than negative 2. So the only number that's less than negative 2 out of our choices is the negative 4. Okay? Final question on here. It says perform the indicated operation and then state the name of the property used. All right, so this is something we've done a lot. This is distribution. So we're going to do negative 6 times a, which is going to give us negative 6a. We're going to do negative 6 times negative 7. Negative times a negative is going to be a positive 42. So that's us performing the indicated operation. Now we just have to state the name of the property, and that is the distributive property. Okay. I hope this was helpful, and have a good day. All right, bye.